Hi, we're going to talk quickly today about z-scores, correlation and coefficient of determination. Basically, going to see how to get those in R, SPSS and R Commander. You can find out details of actually what the output means and how these three values relate to one another by going to the website listed below. The data you can see in the window in SPSS is taken from chapter 15 of Howell's book called Statistical Methods for Psychology. It's an excellent text and I recommend you have a look at it. It's concerning students and evaluation of a course. The first variable, overall, is how satisfied they were with the lectures. The second variable is how satisfied they were with the teaching skills of the instructor. The third variable, exam, is what they thought of the quality of the tests and exams. Fourth variable, knowledge, is concerned with the instructor's knowledge of the material. And the fifth variable is the student's expected grade in the course. Don't bother with the enroll variable. So what we have are 5 ordinal variables. So being that ordinal variables, we can carry out some type of correlation between them. Obviously, we'd expect them to be quite highly correlated, because they really are all concerned with satisfaction of course material and other aspects. Right, so the first thing we really need to do before we carry out any type of correlation is actually to graph the data. And to do that in SPSS, we simply go to Graphs, Legacy Dialogues, Graphs, Legacy Dialogues, Scatter Dot. Graphs, Legacy Dialogues, Scatter Plot. Click on there and you see there's 5 options we have. What we want to choose is the matrix scatter, because we're going to look at the 2x2 variations of overall with teach, overall with exam, overall with knowledge, overall with grade. Right, so here are our variables. We want to choose overall to grade. So click on overall and then push down the shift key and click on grade, and that'll select those 5 variables. Put them in the matrix variables box and then click OK. Then in the output window in SPSS, we have our results there. So you can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scatter plots. Notice that it's symmetrical across the diagonal. That's the same as that one, that is the same as that one, that one's the same as that one. So you really need to look at either the bottom diagonal or top diagonal of the grid. And we can see that teach looks like it's fairly highly correlated, whereas overall and grade and overall and knowledge look like they're quite poorly correlated. But remember, this is with raw scores. And if you look at my handout, my PDF handout, you'll see that I suggest you actually carry out correlations also on standardized scores, that's z-scores. And so we can see how we can produce z-scores next. So to produce z-scores in SPSS, it's quite simple. You go to Analyze, Descriptive Statistics, Descriptives. Analyze Descriptive Statistics, Descriptives. You click on there, again select the variables we want to create the z-score values of. Use the shift key, put them into the variables box, and you'll see down here there's an option, Save Standardized Values as Variables. Click on that and say OK. It goes to the output window just to show us the means, min and max and standard deviation for each of our variables. We've created z-scores, but if we go back to the data by clicking on that icon there, you can see it's added some variables to our data set with Z in front of them. So that's the z-score of overall, z-score of teach, z-score of exam, and z-score of knowledge. And they are simply created by working out the mean value of overall, then taken the individual value from that mean and then divided by the standard deviation of the overall variable. Similarly, the same thing happens for teach, exam, knowledge, grade, then roll. So actually to carry out the correlations, quite simple. We go to Analyze, Correlation, Correlate, Bivariate. So that's Analyze, Correlate, Bivariate. Click on there. Again, put our values in. We know these are ordinal data, so we really could choose Spearman, or just for purpose now I'll choose Spearman and Pearson. I bet there's not much difference between the two. And then we notice we have the option to flag significant correlations with the star rating method, which I'm not too keen on, but we'll leave it in. And we can choose one-tail, two-tail test. And click OK. And we get our results. So you can see that's a table for Spearman's, overall teach, overall exam, overall knowledge, overall grade. And we look above, you see the results for Pearson relations as well. Looking back here, remember that correlations can't really be thought of as a proportion. So we can't say that 83% of the variability between teach and overall is accounted for in a correlation. What we can do is take the square of that value, and then we'll be able to get what's known as the measure coefficient of determination, r squared. That will tell us what percentage we can predict one from the other, which is really much more useful. This time we're going to use a comma delimited file, the same data we've just used in SPSS. I'll show you it here. But export it from SPSS into a comma delimited file, and it produces a .dat extension. So if we just double click on that to see what it looks like, here we are. It's just a text file with tab characters we can't see between each value. And the top row, notice, has the name of each variable or vector column, whatever you want to call it. Our values are down there. So we're going to import this text file this time rather than using the SPSS file. So we've got to load the R commander interface. There's our R commander interface. So to import this tab delimited file, we go to Data, Import Data from Text File. And we're given several options. What is the name of the data frame we're going to put it in? Well, call it the usual thing, my data frame. We know there's the variable names at the top of the file, at the top of the columns, yes. There's no missing data, so we can ignore that. We're going to take it from a file, not from clipboard or from the internet. And we know the field separator is a tab. And we noticed when we were looking at the data that the decimal point is shown by a full stop rather than a comma. Okay, then it asks us where the file is. And now we have the data into via our commander. And click on the Edit Dataset to see the data. Now, first thing we want to do is actually create a graph, a scatter plot of each of these variables that we're interested in, see how closely they bunch around a line, how closely they co-vary. So we could choose scatterplot, which would give us a scatterplot for just two variables. We could choose scatterplot matrix, as we did in SPSS. We can see all the variables we're interested in one go. So we know we're not interested in enroll, which is the number of people enrolled in each course. Just choose the other ones, top one, and then the bottom one. We press down the Shift key, and click. We don't want smooth lines. We'll have the line of best fit. And the diagonals, we'll choose box plot here. Explain all that when we get the output. Okay. And there's our result. So you can see that's teach, overall, knowledge, grade. Remember the last one was exam. So we have it. The correlation between exam and grade is there, shown. Exam and knowledge, scatterplot there. Exam and overall, scatterplot there. Exam and teach, scatterplot there. So just by eyeballing the variables, it looks like the highest correlation we'd expect is between teach and overall, I would say. Remember that the top half of the diagonal is the same as the bottom half, they're symmetrical. Also, while we're here, I just mentioned to you, once you've got this graphic window up in R or R Commander, you can go on to File, Copy to Clipboard, and if you choose as meta file, you can copy that file, that picture, that scatterplot matrix, into a Word document very easily. To convert our values to z-scores if we wished, it's dead easy to do in R Commander. You click on Data, Manage Variables in Active Dataset. So it's Data, Manage Variables in Active Dataset. Then we have several options. If we look fourth one, we have Standardized Variables. So we click on Data, Manage Variables in Active Dataset, Standardized Variables, and then select variables. Again, we want to create z-scores for. Click OK. And then if we go to Edit My Dataset, we can see there we've got, besides our original variables or vectors, we have these new ones, which are the same as we achieved in SPSS. We don't really need to bother about z-scores in this instance because we know that all these variables, except for enroll, which we're not interested in, were scored from 1 to 5. So if we take overall an exam, we know they've both got the same range, the same scale, 1 to 5. But say if we had a variable here that had a range of, say, 0 to 0.1, and the other variable a range of 1 to 1000, the scatterplots would not really look very sensible to work out the correlation value from. Then we would use the z-scores to draw the scatterplots. Right, close down that, and now we'll actually create the correlations. So to do that, we go to Statistics, Summaries, Correlation Matrix. Now notice there's Statistics, Summaries, Correlation Matrix, and Correlation Test. If we wish to create some 95% confidence intervals, we have to use this correlation test. We can only put into that 2 variables at a time, whereas if we use correlation matrix, we can get correlation values and associated p-values for more than 2 variables at a time. So we choose our variables we're interested in. Notice it's given the same naming as it did in SPSS. It's added a z to the z-scores we created. It's interesting in that moment. There we are. We'll choose Pearson. We could choose Spearman as well if we wanted to. Choose this. And don't forget here where it says pairwise p-values. Click yes, we do want those. Okay. And here is our results. Notice that you have to move upwards to actually get the correlation values. They're the correlation values. Again, remember, it's symmetrical via the diagonal. So 0.61, 0.61, 0.45, 0.45. We only need to look at the bottom diagonal, really. So exactly the same as what's in SPSS. And now if we look at the next table, these are the p-values. Notice that quite a lot of them are 0.0000. That doesn't mean that it's actually equal to 0. What it means is it's less than 4 zeros. And we could, if we wanted to, ask R to produce output that goes up to, I think, 16 decimal places, and we probably would get a value at the end there. Right, let's just show you quickly how to create a confidence interval. So where we had statistic, summaries, we choose correlation text here, correlation test, and we'll take exam grade. We can't choose more than one. If you try, you'll get an error message. Pearson, two-sided, and click OK. Notice there's no option for a confidence interval here, but we do get one. OK, and there's our result with the 95% confidence interval. You can use the same code we actually used for the Wilcox test in R to say what we want our width to be. Do we want to be a 90% confidence interval or an 85% confidence interval? So we can change that very easily. I'll just go through quickly some of the main ways of carrying out the analysis we've done in R Commander directly in R. If we actually go back to R Commander and we look up at our output, we can see the actual code, the R code. It's a good way of learning. So if we actually look at how we would create the z-scores, this is saying that we have 1, 2, 3, 4, 5 variables from our my data frame we defined, and we're using this function called scale. Scale's a magic word. It's applying scale to those 5 variables, and what it's doing is creating z-scores for each of those variables, for each of those values, and it's putting it into a matrix called .x. And then that is each of the columns in .z is put into a new variable which is called .zexam.zgrade, which are our normalized variables, and we get rid of that temporary matrix there. So scale is the magic word, magic function we need if we want to create z-scores of any variable. We can also look down at the bottom and see how we obtained the confidence interval. The confidence interval was simply the code core.test, and then, as usual, the 2 vectors, which represented the 2 variables. We wanted a 2-sided p-value, and we wanted Pearson. So that's as simple as just core.test. To produce the scatterplot matrix, there are many commands in R you can use to achieve this. The simplest one is called pairs. First of all, let's just check we've got my data frame in R. So click that. So if you look there, 1, 2, 3, 4, 5. We want the first 5 variables of our data frame. I'll just show you quickly what will happen if you don't specify you want the first 5 variables using this pairs command, which is for the production of a scatter plot. So pairs frame. Say that we have to actually look in the graphic window. And there we are, and we see what we've got actually is all the variables, including the z-scores correlation. And we don't want that, we just want the first 4 variables. So if we actually go back this time and specify, we want just the first 4 vectors, 1 colon first 5, sorry, I have to apologise, first 5, put in square brackets, and that's saying I want you to carry out the scatterplot matrix command, but only on the first 5 variables in my data frame. Run that, there's a window, and now we look at the graphics window, we have what we wanted. Finally, I'd just like to introduce very quickly the idea of using functions, additional functions, that the R documentation provides to produce some enhancements to these diagrams. I've copied the R code above from a handout provided on the R website. You don't need to know what it does in terms of detail. What you need to know is what it does when we use it. And if it's noted, it's panel.core. What it does is produce a set of correlation values in the top right hand side of that scatterplot matrix. We'll see now the effects it has. Here's the command we used before, pairs, But this time we add an extra term in saying we want the upper panel, that's the upper diagonal panel, to use this function that we've copied. Click return. Then we have a look at the graphics window, and here we have it. We have in the bottom left scatterplots, and then in the top right we have the correlation values. Notice the correlation values, the sizes of the text vary dependent upon the size of the correlation. So, what have we done? We've looked at how to obtain z-scores, correlations, the associated probability values and confidence intervals of the correlations, and also looked at the more important coefficient of determination as a method of assessing the degree of covariation between the two variables. And we looked at how to do this in SPSS, R and R Commander. Specifically in R, we looked at the z-score function, which is scale. We looked at scatterplots. We didn't look at a simple scatterplot, which just using the plot command. We looked at the more complicated scatterplot matrix command called pairs, where we could specify certain vectors within a data frame to use in the scatterplot matrix. We also looked at how to obtain correlations using the core command. Finally, we looked at how to obtain the correlation plus the confidence interval for that, which we only could do for two variables at a time. And the code there is below. It's core.test, then two variables, specify which type of correlation you want. I put Pearson there. We want a two-sided p-value and also the level of confidence interval we want to use. So it's 95% there. It should be 0.95. You can find a lot more details in my website given below, and also handouts to do a correlation, specifically how to actually work out a confidence interval within SPSS using syntax, and also what the differences are between Pearson correlation and the Spearman rank correlation, and how this relates to simple regression.